Hello, welcome. I'm Steve Lasker. I'm a program manager at Microsoft. I work on a lot of different technologies, actually. A lot having to do with how to make clients more productive. That relates to enabling offline, so they can work regardless whether the network's actually available, or having local storage, so I don't have to worry about what I can synchronize that data into. And a lot of those kind of features on just how do we make our end users productive, and how do we make you guys productive to enable your end users? So I've worked on things like the data sources window, the type dataset designer, object binding, enabling SQL Server Compact on all the desktop databases now, and the design for sync services for radio.net. So that's the kind of stuff I've been working on. And here we're going to talk about how we can make your apps more productive. And the model is, how do I make them, whether it's online apps and you just want to make them run faster because you have some data locally, or you actually want to make the next logical step to make them fully available offline. So that's what we're going to cover today. If you've been to Philip's session, you've kind of got the base platform of what we're doing with Sync. In this session, we're going to talk specifically how you can leverage your radio.net skills to synchronize relational data. Now, relational data makes it sound a lot more strict than it is in many ways. And we'll see that a little bit through this session. The Sync framework as a whole, as you've probably seen, supports lots of different data source types. We just took the opportunity to ship in Visual Studio 2008 to enable line of business, sort of. I don't want to say sort of like it's less, but it enables more than just line of business, but certainly line of business kind of apps that I want to bring data down from the server and enable users to just be productive. So part of that is related to what I want to cover today is, even in an online app, there could be some productivity here. So we're going to talk about how you can use reference data and keep it locally and actually simplify your programming model and improve the performance, not only from your end users, and not just perception, actual performance, as well as improving the performance of the server as well. If you don't have to ask the server for the same question you just asked it 1,000 times, you can offload quite a bit. If I ask my wife, the same question over time, I'm going to get hit. The DBA tends to do the same thing, I guess, as well. Well, a lot of people have been struggling on, what can I do for a local store? So we get in all these questions that can you sync to XML? Can I sync to different files? We love SQL Server Express, but we also need something that's not always, that power. So we'll talk very briefly around SQL Server Compact, and I have a session on more details on that tomorrow. Now, many of you probably are already working with radio.net. Show of hands. Okay. So how many want to toss out all that knowledge and start over? Anybody? No. There's something really powerful there. And that's what we wanted to do, was take that specific domain knowledge and make it applicable to doing synchronization for data. So we'll talk a bit about that. And we'll also talk a lot around how you can move from two-tier and very simplistic, and I want to say simplistic as a simplistic app. But sometimes you're in an architecture where it's perfectly fine for the client talking directly to the database. Could be point-of-sale systems, or I actually got a guy who pinged me on my blog saying, I've got people in a mine. They're 2 miles underground. I don't need a web server. I just need to get a connection up to the ground, and that's fine. But then I have other people going, I started there, but now I need to go to working over the internet. That's great. And we'll talk about how you can very easily move from two-tier to n-tier. But I'm going to wrap up the last part of the presentation with a demo showing how this fits as a piece of a larger architecture. There's no one-size-fits-all here. Usually I have somebody stand next to me. It's nowhere near my size. So there's different components to an app. And I'm going to wrap up with something I call logical queuing to kind of give you some context of how this fits into a larger architecture. Now, Philip talked a bit about this the other day, or this morning, and Soma talked a little bit about this the other day. There's this next generation of apps where they've kind of making this evolution. It's not really a backwards stop. There's a lot of online connectivity, but it's not always available. So how do I leverage this? And even if the network, what I call burps, how can I still be productive? So there's this hybrid approach starting to happen that many people that have already gone full online realize how painful it is. So then there's, how do I leverage both in this world of leveraging local and remote resources? Now, data often goes to some central location, but as we've also seen, the data tends to propagate across lots of different places. And I want to be able to synchronize that in a very collaborative environment. And that's what the Sync framework allows us to do, is be able to say, there is no master owner of data. It's kind of in lots of different places. In this session today, I'm going to talk more around, I have a central authority in a database, and I want to replicate it or synchronize it out to lots of different places. And it's related to everything from line of business kind of scenarios to more consumer scenarios. So that's the kind of idea of the span of what we're doing with the overall Sync framework. Now, a lot of times people will say, well, I don't really need to go offline, but I want to be able to cache. And that's what I want to kind of talk about here for a second, just kind of give you an idea, because you see caching simplifies data access. You go, well, wait a minute, maintaining a cache is not simple. Well, if you take a look at the bigger picture, it can be. Now here, I've got a scenario where, typical thing, right? You got an app, and you got dozens of questions you need to ask of the data. The products that start with a certain letter, the products in a certain category, the products might be within the top selling products over the last 3 months. And for each one of those questions, we need the DBA, who's going to write the stored procedure, write the view, create the indexes, set the permission, do all of that stuff to make sure it actually scales. And then we have the service developer, who's actually got to create the web service, WCF service, whatever it is that you're communicating over. And then you got another person who's got to consume that service and write the proxy and implement the contracts and all of this goo. And then finally, you can start painting pixels on the screen for your users can start working with the app. Now, this might be 4 people, or it might be 1 person with multiple hats. The point is there's all these parts of your app that you need to maintain to talk from one end to another. And it starts to get complex as soon as you get out of the demo scenarios. Now here you got your business guy, right? The guy in a tie, because he's the only reason he's wearing a tie, right? None of us wear ties to work, do you? Anybody wear a tie to work? They have to? Sorry. Anybody else want to hire him? Give him an opportunity to relax? I worked at Mary Kay for a while as a consultant, and they required me to wear this suit and tie. And luckily, I was doing enough for them. I was able to just keep it hanging up in the corner. And as long as I had it available, I could put on if somebody important came by. That was okay. But anyway, you got these people, they're representing your end users, and they have needs. And this app is a week before going into production, and the users love the app, but they want one more query to come out of it. And the DBA is like, no way, I just spent a week, tuning the database and doing all this load testing. There's just no way I'm making that. You can do that in the next version. Well, that's not exactly very friendly, right? I got a week, 2 weeks left in this. Why can't we just add one more query? Well, the idea is to offload some of the details to the client. So now, instead of asking the server every one of those detailed questions, I could now ask the server for what changed, right? And then I could start looking locally and start asking those questions of the local store. Now, many of you are probably staying here in a hotel. How many of your hotels have a refrigerator in it? Why? You guys have room service? There's plenty of restaurants around. Right? We probably have refrigerators at home. Even in college, we have these little mini fridges. We got this culture of I want things closer to me. I might go shopping. I want my things that I want to be able to make available when I need it. I just want to synchronize the resources back to my local place, the refrigerator, the pantry, my local store. So I have information so I could cook up the questions that I care about. So in this case, as long as I have the raw materials, the data that user needs, that business guy can go get that question answered very easily without even affecting the DBA if you've taken this kind of approach. And of course, you're already set up that if the network's not available, whether it burped or you're literally offline, you're already halfway there. Where up here, anything happens, you're just dead. Right? You're back to 404 errors or some other error, and you just go, hey, not my problem. The network guys should have kept things going. So if you guys want to go make the internet 100% reliable, more power to you. Or we can make it more realistic and kind of go through it. So here, With this model of caching that reference data, the data that's relative to that user, I can now just start making this very productive. And a week, a day before the app goes into production, you can actually add that functionality. Because if it doesn't perform well, who cares? It's for one user. There's no multiplier, which is the problem we have when the developer hands the query that worked perfectly fine for him or her to the DBA, and they're like, no way you're running this on my server. So now we're going to get into some of the how-tos. Well, there's a lot of questions now. Well, how do I get past the next layer? And what do I use for a local cache? Because I need something that I can easily deploy. I want to maintain that cache with just incremental changes. I don't want to have to take the entire 5,000 product catalog and bring the whole thing down each time. Leverage my ADO.NET skills so I don't have to start over. And nobody wants to read the 1,000-page book to do the simple thing. I'll learn a little bit, get me so far, I'll learn a little bit more, a little bit more, a little bit more. So we have a very incremental approach to how we've gone about this. Everything from the runtime to the dependencies to the design time scenarios that we're supporting here. And the last one is, how do I not freak my DBA out with all these requests so I want to start synchronizing data? Because they're all being taught, get all the data in the data center. No data goes out. Right? Well, I got to make it useful. So we can actually make this very easy for your DBA to start using today, and it gets even better as we start to add more features in SQL Server 2008. Now, to take a picture of the approach that we're taking here, there's different caching approaches. There's the ones where I'm just monitoring the things that come across the network, and I'm just sneaking those things locally. That doesn't work so well. It's not that it doesn't work at all. There's definitely scenarios where it can work. The model we are designing around, and not that you can't use this for those other middle caching models as well. The approach we're taking is more of the Outlook approach. I have resources locally, and I synchronize those. All right, I can cook up, spaghetti, meatballs, pasta, whatever it is that you're flavoring, and you can season it up because you got all the raw materials locally. But maybe you guys here can do a better job of making pizza. We have to order out a pizza in the States to get good pizza, because even the frozen stuff ain't so good. So you still have online things you're going to communicate to, and you're only going to have those in an online. There's certain places that's just what makes sense. In Exchange, it might be public folders, right? But my mail, I want locally. And then the local resources you could synchronize. And I'll talk about the logical queuing for working with existing services towards the end. Now, local storage. The challenge there is I need something that I could work with. And when I have the power of SQL Server, that's great, or the ability to do that. So this is my only marketing-ish slide, but it just helps put the context in here. With SQL Server, we have a pretty vast array of ability to store. So we've got all the way from the biggest data center down to this Hello Kitty. I swear, we actually have this Hello Kitty that actually runs Windows embedded. And I guess it speaks or talks or burps. I don't know what it does here. So we can actually run everything from that all the way up to the top of your largest data center with our SQL Server product line. With SQL Server Compact, we have consistency across all our clients, whether it be a gas pump or a point of sale system or a desktop, PDAs, things that are scanning tickets as you're going to the stadium or whatever. Same engine, same programming model, same focus on footprint being the deployment footprint being the priority. When you want the priority of SQL Server, you want the server-style programming model, we have SQL Server Express that you could run on your desktops as well. So you really have a choice there. Consistency with the server, deployment isn't the factor. Consistency on the client, deployment is the prime factor. And tomorrow I'll do a talk specifically on SQL Server Compact to drill in that. And here's just the one slide on it. It's very small, 1 megabyte of DLLs. Add the DLLs to your project and ship it. It's smaller than an empty SQL Express data file. It's smaller than a data set, probably smaller than some of the pictures you might have in your app. And we'll drill into all the details on that tomorrow. So once I have a local cache, how do I synchronize it? Now, we talked a bit about how you're probably familiar with ADO.NET. So I wanted to do this animation here to kind of map how the data adapter model is how we modeled sync services and was the basis for it. So with data adapter, we basically have the model that you take a query, you submit it to the data adapter, it's got a select command, It submits it to the select command, and then it can query the database, and it returns a data set in this case, right, or payload. You make changes to it, and you send it back, and it shreds it to these insert, update, and delete statements. Right? Very simple. You've got designers that give you the primer for those commands, and when you want to drill in, you can go to the command text, change the query, change it to a stored procedure, a view, tabular function, all different choices on how you want to work with that. Right? Start high level, drill in as you want. The data set gives us the ability to work in 2-tier or n-tier because it does serialization. There's a lot of great flexibility here on how we can go about this. But all operations must round trip to the server. I'm really not leveraging the client, to work with this data set. Data set's very powerful, but we start getting emails around, hey, I got 1 million rows in my data set. How come it doesn't perform very well? Well, because it's not a database. It's not what it was designed to do. You're hitting the limits of what we designed data set to be designed for. And of course, with this model, we're very fragile in network stability. Right? Data set will run in memory, but you reboot your machine or you try to submit it, you got problems there. So with sync services for ADO.NET, what we did is we took the data adapter, and we have a sync adapter. And then we take the select commands, and we expand it out, because now I need to start getting incremental changes. That's what's important about sync. Anybody can select everything and store it, and select everything again and store it. The efficiency is, can I figure out what's changed? And there's details for inserts, updates, and deletes. And those queries, depending on how your database is structured, you may need to have an individual command. Now, you can also do just select incremental updates. And if you can get inserts in that, that'll work as well. We have upsert functionality on both sides. Now, we also expanded on the ability to capture conflicts. So we have the updated rows and the deleted rows, which might be in separate tables depending on how you're tracking them. So those are just additional commands as well. So now, the whole idea, though, is, well, if I can do all this synchronization, I don't want to do it in memory. I want to do something to some kind of persisted storage. So that's where we can bring this in, and we can synchronize. In this case, I'm showing SQL Server Compact. We'll be shipping an Express provider as well. But here, we're going to focus on Compact here. And then, again, now that I got the data there, I can work with it. Now, because Compact gives us the ability to work with it across multiple threads and multiple processes, I could have that running on another background thread, or I could have a whole other application doing synchronization into my store, and then I can just work with it locally. And of course, as I'm offline, the user's fine. But they're still ordering pizza, direct online. So you can still make calls to web services. It's not meant to be a replacement thereof. It's an augmentation to your app to enhance a lot of the data that's available to you. Now, all that's great, but yeah, we always give promises around how easy it is. Show me. So let me go show you here in Visual Studio. So this is Visual Studio 2008. So what I'm going to do here is we're going to create an application, and we'll call it the Tech Ed Demo. Now, I happen to be using VB. How many are using VB? How many are using C#? Okay, you're outnumbered. Whatever, the other way. Anyway, it doesn't matter. I'll give you some C# code as well. But you'll see that for the point of this, it just doesn't matter. So, and I'm happy enough you're using .NET, so don't worry about it. So I'll say add new item. And here we start to see, because for those of you who remember last year when we were talking about our SQL Server Compact database that was showing up everywhere, we've gotten problems with names. So we've started just name things around scenarios. You see local database, service-based database, Express, Compact. Or I can choose the local database cache. So here, what I want to do is I want to cache my lookup tables for ordering online orders. So I'm going to talk to the server for my orders table. But if you know the Northwind database and orders, I have customers, employees, and shippers. I want to cache that information locally. I don't want to keep asking the server for that. So I'll come over here and I'll say, I want to talk to SQL Server. We'll automatically configure a SQL CE database for you here locally. I can change the name, I can change some certain things about it there. And then I'll choose what tables I want to actually bring down and cache locally. So customers, employees, and shippers. Now in this case, my database doesn't actually have columns on it that I can use for tracking. If you already have a timestamp column on your tables or a date time column on your table that you're monolithically increasing, we can choose from those. Okay? If you don't, we'll help you add them. If you don't have access to the database, you can choose to just get the whole thing each time. Right? So you have some options here on how deep you want to get into the database. So by default, we assume you're in development and you can enhance this a little bit more. So I'm going to press OK. And what Visual Studio will do is do some altering on my database for those tracking columns. And it'll save the scripts, both the apply scripts that you can give to your DBA, and she can come back to you and tell you whether there's no freaking way you're putting that on their database. Here's what you can do. Or you can just roll it into production and replay it. And we have the undo scripts as well. So at this point, I'll just press OK. And now what the designer is going to do is configure, instance, and run the sync runtime. So now those tables already got created and synchronized into a SQL C database. Got it added to my project right here. And as soon as you add a SQL C database or a SQL Server database, we automatically launch the data sources wizard. Now, I want to be really careful and separating something here. I'm showing a really good end-to-end scenario. I happen to be showing it with Windows Forms because it's the most productive right now. The same technology works with WPF as well. Just like I don't care whether you're using VB or C#, for the point of this, I actually don't care whether you're using WPF or WinForms. It works equally in both. And the programming model, once I get the data into SQL CE, we actually don't care whether you use link to SQL, link to entities, or dataset in this case. I'm going to use dataset just because it's just easy for me to pull up here. So I've got that. And now I've got my dataset that's got those 3 lookup tables that are actually bringing from the local SQL CE store. What I want to do is I'm going to go add the orders table from the server. So now I've got a data set that's mixed with some data from tables from my local store and my remote store. And again, it's helpful to pull this together. So now I use the data sources window, and we'll just quickly change this around so I can drag and drop this. So have you guys seen all this demo already? Anybody not seen how you can just kind of change the controls and drag and drop this? No? Okay, good. This actually is in Visual Studio 2005, so it's just some people didn't realize that. So I can just drag and drop now and drop these tables onto the combo boxes, and we'll automatically configure the selected value, text, display value, and so forth. So now I can just run this. Now before I run this, I'm actually going to launch SQL Trace. So when I run this, what you'll see is only the orders table is actually going to get queried from the server. These combo boxes are all loaded locally because I already have them cached in SQL CE. Right? So it's just my orders table is all I see. All right, well, that's great. I can do that with dataset and write to XML. No big deal there. Must be something interesting there. Well, the idea is, how do I get those incremental changes? So I'm going to go add a button here for like the sync now functionality. Now, what code do I put behind the button? We can send you off to help and make you go search and try to figure it out. What we did to try to make it a little helpful is we give you a code snippet. And, codes. And now I could paste this. And if you're C#, we'll give you C# code. We're in VB. We'll give you VB. I'll make it for the C# guys. There you go. Does that help? All right. So now that I've got my synchronize, right, because what I'm going to do is instance the sync agent that was configured for me. It's a runtime. You can completely hand code this if you want. I just didn't feel like taking an hour just to go through all the details. We'll show how you can extend it. And then you call synchronize, and it returns the stats. Now, the thing to realize here is link to dataset, link to entities, link to SQL, they all make copies of the data into memory. So, and I've just synchronized my data into SQL CE. It's not what I'm probably data bound to in the form. So we put a little comment here just to remind you. And we do have a linked, a SQL C result set that actually isn't a copy, which I'll demo tomorrow. But here, I need to go me.northwinddataset.customers.merge. I'll use the dataset API, and me.customers table adapter. .get data. It's how I can get the data out of SQL CE and merge it into my data set. This is an API we added in .NET Framework 2.0. So now, let me just reset this here. Now when I run this again, when I get my form running and I got SQL Trace still there, what I can do is I'll come over here to Management Studio, and I'm going to update customers and set ALFKey here to have another value. And if we look, we can see, all the noise. So update customers, and anyway, why is that all noisy? So update in here somewhere. There we go. So update customers, so I've set it on the server. But on the client, I want to get that value into my combo box. So what I can do is I'm just going to call the sync now function. It's going to instance the sync agent, run those commands that were automatically generated for me. And if we look, for each table, there's basically 3 queries. Select the things that were inserted. Creation date was less than the anchor that I have. Updates, last edit date. And deletes. We sent things off to a tombstone table. Here we go. For where deletes were done. Okay? Now, the gentleman before asked me about filtering. These are just SQL statements. You can write selects that have where clauses, that have joins, whatever you can write in a T-SQL statement, you can put them in here. And through the sync runtime, you can take from the client and pass up the value for one of those parameters. Or on the server, you can determine, based on who the user is as they were connected, what that parameter should be. So you have lots and lots of flexibility here on how you can get into that. And here we just see the same thing for the next table. So for each table, we have 3 queries for what did you change? Okay. So that kind of gives a quick view of how we can take these sync adapters, configure them in the designer. You're very familiar with what it is to do commands. Hopefully that was pretty familiar to you. Well, where does this fit in the bigger picture of how the sync framework works together? So what the sync designer did was, in addition to configuring the sync adapter over here, we've also configured a bunch of other components. So when you do sync, I've got orders and order details. I might have customers, orders, order details. And if I inserted all 3 of them or deleted one of them, we need to delete them from the bottoms up and insert them from the top down. So the server sync provider has a collection, and the order of items in that collection is the order that we'll do from the top down and bottom up. So we actually do the hierarchical update scenarios right here in the sync runtime. The sync agent is the middle guy. He's the thing that's configured with a local provider and a remote provider. And he's got a local provider, in this case, that's SQL CE. And we have the client configuration of sync tables and sync groups as well. Now, one of the things we have with merge replication is you create these publications. And you say, here's what I'm going to make you synchronize. And the client says, I only need these 3 tables. No, you're going to get all 12. Well, I don't want all 12. I want 3. No, just ignore the other 6, 9. Sorry, wrong math. So here, we have a lot more focus on developer control. So here, the server can say, I want to make 12 available, that bidirectional upload, download, whatever, and the client can determine how much of that they need. Now, that doesn't mean it's going to violate any constraints on the server. All of that still lives on the server, and we'll talk about that in a minute. So now we're starting, we got the download, right? We showed how we get incremental changes on the download, showed you the commands. I didn't get into the filtering, but there's a filtering parameter on there, so you can send those up. It's really good for well, how do you do upload? How do I make changes locally and get those to go back up? Well, when the data is well partitioned, when I want to send things up in batches, Sync services and the sync framework can work really well for that, right? We can send things up, we can track when there's conflicts, we can do business rules, both on the client and on the server, and there's a lot of functionality in there. And we'll drill into that. And we can do that by extending the designer-generated code. I'll do a demo in a minute. But that doesn't really fit all architectures. Sometimes I have existing services, I can't make changes to that service. I have a service that knows how to take an order, why can't I just work with that? So we'll talk about that in another demo I'll do with something I call logical queuing, when there's more workflow required. So what I want to do is take what I just started with, right? I did this create new project here. I didn't have to, no can drag code here. I want to now do upload of changes. So what I'm going to do is we're going to take that customers table and we're going to enable it for upload. Now if we look at the sync designer itself doesn't actually have any upload capabilities. There's no options on there. But we did actually generate the upload commands. It was just a matter of how much we felt we could expose in the designer in that incremental approach. But if I say view code here, I can now use partial classes to extend the designer. So in here, I could just say this, customers.sync direction, and notice I've got a number of different directional options. By default, it's download only. That's what the designer generated. I can do snapshot, grab me the whole thing each time, upload only when I'm doing local data capture for things like barcodes and other things. Or in this case, I went bidirectional. So with one-liner, wrong way. Okay. One-liner, you can actually change this and do bidirectional and start changing things up. But what about conflicts? Okay. Partial public class. I'll have a server sync provider and the client sync provider. So I can actually get conflicts on both sides and capture them. So in this case, I'll use the VB event wiring up, but I can do this with C# as well. That's why we see a partial method here. C# doesn't have the handles concept, but I can use onInitialized, and I can do my event declaration in C# as well. So in the apply changes failed, we can get the changes back. There's a conflict. I've got server change and client change. So that's actually a data table. Server change. Data table equals. And then I can do dim server change. Oops. So now I've got the data back. So now when I've got a conflict, I can see, well, the server had this, the client had this. The user is this person, so I can make some additional logic and decide. And then I got it twice. You guys are quiet. Usually I get somebody yelling at me by now. What are you doing? You got red squigglies there, or blue squigglies. And then what you can do is you can actually look at the whole thing. So changes to be applied as dataset equals e.context.dataset. So this is the server and client. This is actually what's about to be applied. I can make changes to that. I can do that with link to dataset. I can do a link to the database and get additional stuff back. And then I could say e.action equals retry with force right, because I'll make the changes and I want to resubmit that. So I have lots of different options here. So I'll put a breakpoint on that. And now let's create a form to consume that. And for simplicity here, I'm just going to blow away form 1 and we'll add a new Windows form. And we'll put customers on here. Doc and parent container. And then we'll just put the sync code back there, the sync now button. We'll go to the cache, grab that snippet of code, paste it in, and then do the merge again. E.Northwind dataset, customers.merge, E.customers table adapter, .get data. Okay, same thing. Right? So now let's run this again. And now I've got my form. We'll come over to the region and we'll say clients. And I'm going to save this locally. And let me just go back over here to Management Studio. Oh, sorry, actually, SQL Trace. We'll clear that. On Management Studio, we're just going to select the region, and we'll see that it's still null. And then we'll do a sync. So what it's going to do is the first thing, in most sync topologies, you usually take the local changes and you push them up first. So that's what we're doing here. We simply do an update statement, updates the value for region up on the server, and then we bring the server changes back down to the client. So you can get, if there's server-side defaults that were applied, business rules, so forth, you get those changes back down to the client. Now there's opportunities to not echo the changes on the server at the client as well, using a client ID, but that's the next step beyond. And now, if we execute that again, we have the client change up on the server. So great, I got data moving from bottoms up, top down, sideways, leftways, whatever. What happens when there's actually a conflict? So let's go back and reset the customers to null on the server. And I'm going to go make a change here and say, yeah, it's client 2 now. So I've got a change on the client and a change on the server. Save this. And now we will, well, I set the breakpoint, right? Let me just make sure I set my breakpoint there. Yes. So now I'm going to do the sync. And surprise, surprise, I have a conflict. So we'll step over that. We'll look at the server changes, get the nice little IntelliSense here. Region's null. On the client change, client 2. So I now have the values of both the server and the client, and I can determine what I want to do with it. In fact, what I'm going to do is go to the changes applied and say, yeah, I actually want that to be foo. Okay, so now in memory, I'm all set. I've made my business logic changes. I've done whatever I need to do, and we'll hit F5. And surprise, surprise, I've got foo now in my client. And if I come up here, I got foo on the server. So you've got complete control over where you want to handle that. In fact, I could actually handle the conflict on the client. There's lots of apps where the client app needs to actually be in control, and the server doesn't actually have the authority. I might have a client that's talking to lots of different services. So just like I showed the server sync provider, there's a client sync provider set of events as well. In fact, if we look closely at this, there's applying changes, changes applied, changes selected, selecting changes. There's all the gazintas and gazoutas you need to handle business logic and anything you need on either side of the synchronization model. Okay? All right. Let's see. Stop that. Come back over here. All right. So we kind of showed we've got the sync designer. We do the download reference data. We generated the commands. Conflicts can occur. We have several different events you can tie into. And you can run all your business rules in there. Now, what I showed was two-tier, right? All the SQL commands are running on the client, right? It's fine. The guy in the mine, he's happy, right? The point of sale system guy, he's perfectly fine. Now, the guy that's trying to talk across the internet, and it's got somebody that knows quite a bit about some code and could probably sneak in there and find the connection string in the app config or whatever, not so good, right? We need to actually take the next level. I need to be able to communicate over web services, over the internet. In fact, I actually don't know what you want to communicate over. So with Visual Studio 2008, we've taken the ability to prime this with WCF. Now, as Philip talked about, we actually don't care what transport and protocol you use. We have some out-of-the-box functionality, so if you really don't care, you can use something out of the box. If you really do care, you can go change it, okay? We've just given you some abilities to take that further with WCF so you can get along the way. In fact, if you want to synchronize over jelly beans and you can figure out how to turn that into whatever, That's fine. You need a jelly bean converter on both sides. As long as they're matching pairs, we're good to go. Now, what I showed here was this architecture, and that big blue box is the client. So all the stuff is running on the client. What we want to do is we want to move the green stuff over to the server, right? Running on your web server, running on another server, and you're just communicating over sockets. With WCF, it's a great opportunity to say, we don't care. There's lots of people in Microsoft figuring out transport and security. We wanted to get out of that business. So all I need is a matching pair of the service and proxy. Put the Jelly Bean service and proxy on either side. Take data sets, turn them into another form of XML. Use SSE. Doesn't matter. We have an API that we expose, and you can put anything you want in the middle there. So all we want to do, though, is shim in the service to make that work. So come over, same project, and now what we'll do is if you come to the Sync Designer, and now you start poking around the Advanced button, we notice we have the ability to separate the client and the server components. So here, server project, I don't actually have any projects yet. So let's go add one. I'm going to add a new project. I'll do a WCF project in this case, WCF service library. And now through this we get the contract and so forth, but I don't want that. I want the sync one. So we'll close this. Now in the Sync Designer, I can now target the WCF service project. So all those green boxes are now going to move over to the other project. It's going to reconfigure them, split them out. In fact, when I go to try to build here, I'm going to get a build failure because the applying changes failed for the partial class of the Northwind Cache Server Sync Provider. Is no longer in the client project. All right, so I'll go and cut this. And I'll come over to the WCF project. I'll say View Code, and I'll put it in this partial class. Okay, so I've split it out. Now, I said assisted configure. We didn't do the whole thing end-to-end as much as I would like to. So if I look at the contract now, we've created a contract for you. We've implemented that contract, and we've just wrapped this configured server sync provider. Now, this code is your code. So if you want to synchronize in another format, another serialization, you want to pass up other parameters to the WCF service, absolutely positively. We have no idea exactly how you're going to do it. So this is where that flexibility really gives you a lot of power. Now, turns out WCF is not always that simple to get everything set. XML is great. So what we've helped you with is we've given you some of the snippets to configure your app config. So I'm going to come over here, and I'm just going to copy and paste the service here. Now, I'm not drilling into a whole bunch of stuff around WCF. There's lots of great sessions here to cover that. I'm just going to quickly configure this. So I need a service, and I need a behavior. We'll come down here, behaviors, and I'll paste in the behavior. And now I've got my WCF service all set. I'll do a build. Life's good. I'll come back over to my client project. And I'm going to say add service reference. So this is post beta 2 you're looking at. So in post beta 2, we do have the automatic discovery working. In beta 2, you had to actually manually start this, but you'll be able to get this soon. So I'll choose that service. I'll expand that out. The self-hosting for WCF will spin up. And now I can call this the sync service reference. And I'll press OK. All right, WCF service is all set up. I can consume it now from the client. I'm not actually on the Redmond domain, so I need to get rid of that line. Okay. So I got my WCF service. I'm consuming it for my project. I have one last piece. I need to tell the sync agent where it's getting to the remote provider. I'll say view code. And then on the onInitialize, I'll say me.remote provider equals new, what do I call it? The sync service, what do we call it? Did I not spell sync right? I hear people, oh, sorry, it's hard to hear you. Oh, there, sync service reference. Oh, I see what I did. There we go. Now, should be good to go, right? I got my sync service reference. I set it to the remote provider. No. So this is where we start to trip over with base classes. Turns out WCF has its base class. We needed a base class for the providers. So because we didn't want to make the sync runtime tied to a particular implementation, we did not want to use any of the contracts from either one of them, the interfaces. So to make this easier, we use something we call a proxy type wrapper. So let me just simplify this a little bit. And what I'm going to do here is put that there. New provider sync, server sync provider. And in there, I can pass in the provider. So we basically just do reflection and map the method names across. So we can use WCF, web services, the jelly bean converter thing that you've got, whatever it is. Of course, you can wrap this in any way you want. All right. So now I got everything split up. My client doesn't have any intimate knowledge of the server, no connection strings, no T-SQL, no Sprock names. All it's got is the service to communicate. What's behind that service? Client doesn't know, doesn't care, shouldn't know or care. We'll run this again. And now, nothing great, nothing wonderful here. I'm just going to save it, synchronize, and now I am sending my data from the client to the server, and it all happened over end here. And we got foobar up on the server. Okay? A golf clap going there, yeah. Thank you. All right, so where are we? Get back over here. All right, I'll take a brief stop there. Actually, let me show you one thing here to make this really relevant. So when we generated those scripts on the server, to make it work really efficiently, we needed the ability to get some change tracking out of the server. Now with sync services for ADO.NET, we have what we call a good, better, best model. Good, any ADO.NET provider. Oracle, Sybase, DB2, whatever. You got an ADO.NET provider, you can synchronize to it. Better, the sync designer knows how to work with SQL Server. We have a few people in the building, we know who to talk to, we actually can configure that pretty well. Best is SQL Server 2008. We've taken the ability to have, or the need to have these tracking columns and triggers that we put on the table to make sure that those changes are kept there, which means you see triggers and you see these columns showing up in your select star commands. Nobody ever uses those, right? So we now can enable it lower level in the database. So, sorry, I meant to hide that slide. So with SQL Server change tracking, and Philip will cover this a little bit more on Friday, we can actually enable change tracking at the database level, low level in the engine. So we don't have the performance hit of triggers. We don't have to expose additional user columns. For those of you using merge replication, you see the row GUID. We're going to make that go away. So you don't have to see any of that goo. So and like I said, we can improve performance. Now to enable that, it's simply alter database, enable change tracking. It's built into the UI. You can then go to a table, and then you can actually say whether you want to track columns as well. And you can set permissions for things as well. So very, very productive with SQL Server 2008, but not required. We just want to give you, a reason to go there. All right, so what did we cover so far? Covered a lot here. I covered by synchronizing two-tier, right? We've got SQL Server Compact as our local cache, and we automatically create the schema, the data. We actually even create the database for you on the fly. You don't have to actually manually create everything. You can. You can actually create the database, even create the schema, and we'll try to synchronize in it. And if you're bringing ints and you have an in-varchar, that'll work. That'll be perfectly fine. So we don't have a lot of restrictions. We have a lot of flexibility. It also means you'll shoot yourself in the foot, but sometimes you aim very well and you have a reason for doing that. That's part of the power there. And the idea there is we've shown how we can do upload of changing with the business logic. And we moved to N tier because I want to have the simplicity of 2-tier, but I want to be able to go to N tier without having to completely rip everything apart and start over again. Now, when you're using the sync runtime, we're sending things up in batches. And you can break up those batches as well, so we can get some optimizations. But it's not really, here's an order. Right? There's other, sometimes you have these services. So how do you work with existing services? So I have this architecture here. So this is where I'm breaking out and taking into the one-size-does-not-fit-all approach. I want to just take a picture here to show how this fits and probably a more realistic architecture for your apps. Now with service queuing, I might very easily cache my reference data. I might even send the things back up. So I might be ordering goods, and until I submit them for order, maybe I want to synchronize them back with the server. So at the office, I've got a nice switch box. I got my desktop. I got my laptop. I might be writing, composing an email, and I forgot which machine I'm on, right? And I'm running late, so I run out, catch my kids' lacrosse game, whatever, and then after the game, I go back home, and I want to finish that email. Well, it turns out I was actually writing it on my desktop computer in the office. But because Outlook synchronizes the drafts, I can actually get it via OWA on the server. My laptop, when it synchronizes, it can get that draft as well. There wasn't a lot of complex workflow. There was no need to send it and route it. It was simply synchronizing it between 2 points. So we can do that same model here. Now, I can create the orders off this reference data. Right? I've got my product catalog, I've got my customers, and so forth. And when I want to save it, I might want to talk online. And I submit it, right? In the save, anybody notice the save buttons are still floppies? Who's old enough to remember floppies? Now, I don't know whether it's going to turn into a USB key. I'm not sure what the equivalent is to that, but look close at the icon. So when you save, we run some order processing logic. We package it up in whatever the format it is we need to send to that service. And then we call the service, and the service shreds it to all the different systems we have in the back end. But if it's not online, what do? Tell your user to just wait, and by the way, don't reboot your computer? That's not practical. But it's MSMQ, I can put that in a blob, cool. Well, is that so cool, right? I mean, the concept, it works, right? Network's available, it pulls it out of the queue. Well, what if I want to work on that data before it gets sent? Right? It's Saturday evening. I broke up with my girlfriend. I'm pissed. I write her a mail, regular mail, right? I put it in the slot because I lived in New York, and you put it in the mail slot, and it goes into the basement, right? And it sits there locked up until Monday when the post guy shows up. Sunday, we made up. What do? I got the mail sitting in the lockbox below, and I got no way to go get it unless I'm going to get arrested for, I go live at her house for a while and try to steal the mail. So what if I've got an order, and I'm sitting there, and I mark it good to go, right? I put a stamp on it. I put it on the corner of my desk. And when the postman comes by, he sees it. Hey, you got any mail? Yeah, it's right there. I take it. But if I want to make a change to it before he actually comes, no problem. I can just play with it. So the idea is now that I've got a mailbox that I can work with, I've got a local cache that I can store my data in, that in the save operation, before you process it, just save it in its original format, mark it good to go, change the order state, and now you can go make changes on it so that when the network's available, you get an event. That event triggers to go get your order processing logic. You shim in a little piece of code that knows how to rehydrate that from the database, and then sends it on its way, packages it up, shreds it out, and all that order processing logic happens on the server, right? So all we did is we split the things up into two pieces. It's the same code. We just broke it in half and said, hey, part of the save, I won't do it. I'll actually save it locally. If I'm network connected, it's going to go grab it right away and send it. I broke up the code into two pieces. So let's see how this can work. So I got a logical queuing demo. This demo is actually available on my blog. And what we'll do is we'll run this. Now, what I've got here is I've just got this order form. Let me go put the network, not that one. I set this up with a loopback adapter because I never trust real networks. I don't need some Windows update coming right in the middle of my demo. So I'm going to run this here, and I'll just trigger this. But I'm creating this order, right? The guy orders, 10 products, maybe 20 of these. And I mark it, submit for processing, and I save it, right? And I'm running out the door to my next customer. He goes, whoa, hold up. Actually, I forgot, I have a party coming this weekend. I need more of those. Give me 100 of those. Give me 50 of those guys. And notice, I can still edit this. It's marked good to go, but it hasn't been sent yet. So I can play with this. I can query on it. I can figure how much orders I've done to the day. I know if I've hit my quota, right? You can run all the different operations on that because it's all saved locally. So now I'm all good. I go out. I go to the Starbucks, right? Hook up. That didn't sound good. I get network connected. And then it comes on and says available. And notice my network is now online. And the code ran in the background. Queried the database. What's marked sent for processing? What did I say? It said submit for processing. Grabbed it, submitted it, changed it to sent for processing, and lo and behold, I can't make any changes anymore. Right? So you have all the components here to pull this together. So now later on in the day, or right then, we sync, and I could actually see it's being processed. Because it all happened on the back end somewhere. So you could start to see the workflow starting to kick in. Eventually it might be submitted or fulfilled, or it might be back ordered. It might get kicked back to me. So I might have to go back and make changes to it. So lots of different models on how you could pull this together. So if we look here, and you've probably seen different pieces of this. There's a network is available, a piece of code in here. Let's see, order form, view code. So when the network availability, let's see, I've got that up here. I'm just capturing that event. I'm even using the add handler here, similar to C# stuff, or I wire up an add event callback. And in the callback, let's see here, where'd I go? Oh, there it is. In the callback, the first thing I'm going to do is I'm going to set the network available controls. It's going to go through, go to definition, and we basically loop it in to make sure I'm actually on the UI thread because I might have been running on a background thread. And then if the network is available, I set some text on there, right? And it just kind of goes through. So you kind of get the idea. And then in the code, I'm just querying. So all of that is basic stuff you can see. It's just wiring up all individual components that we already have in there. And the piece that we really focused on here is how do we actually synchronize the data and break it up to work with my services. So here, again, we just kind of broke it up. We split out the save and send to service as separate operations. I'm synchronizing my local data. I might even be synchronizing my data back up. I can wire in the business logic and conflict detection and all of that kind of stuff right in there. So that's all good to go. So kind of pulling it into the end here. So we've been working on this, what we call occasionally connected systems vision for a while now. And we've been working on iterating quickly so that we can kind of give this to you as quick as we can give the components as we've got end-to-end experiences. In Visual Studio 2005 Service Pack 1, last year, about the same TechEd conference, we released SQL Server Compact, so you can very easily deploy this in your app, and you can start leveraging that as a local store. With Visual Studio 2008, we're shipping sync services for ADO.NET, our first provider for the sync framework. So you can work with relational data. You've got a great designer experience to pull that together. Now, interestingly enough, because the way the framework is layered, 2.0, 3.0, 3.5, we actually can use the sync framework and sync services for ADO.NET on 2.0 of the framework. So if you have customers that already have framework 2.0 out there, and for whatever reason you can't get 3.5 yet, no problem. You can use this with Visual Studio 2008 and the multi-targeting, or you can add these DLLs to 2005. You won't get the designer support, because it's part of Visual Studio 2008, but you can still code to it. In fact, you can copy and paste the code from 2008 over if you've got it. So you've got great support there. In SQL Server 2008, we're working to make it even easier. We're adding the change tracking features to SQL Server so that we can be more efficient around those tracking columns and the triggers. So you have an opportunity and a motivation in some way to move to SQL Server 2008, but if you can't get there, no problem. We'll still work with you in 2000, 2005, and Oracle and so forth. We're adding the collab for peer-to-peer and the additional data sources that you can start to work with the sync framework as well. So wrapping up some of the products, we talked about SQL Server Compact. We're basically putting the database in your app as opposed to putting the app in the database or putting a server on the client. Again, that's perfectly, if you want to do that, that's perfectly fine, but we now have some options here. I'll talk more about SQL Server Compact tomorrow. And with sync services for ADO.NET, we actually are shipping sync services for ADO.NET in SQL Server Compact. So it's just a matter of the packaging of what we can get done quickly. That's a temporary thing. We'll be factoring that out in later, so you'll be able to get that separately. But today, that's where it ships. It ships with Visual Studio. It'll run on the framework. You can download it separate from the web. It's not actually in the .NET framework, by the way, neither sync services or SQL Server Compact. And it's not because we didn't want to put it there, or that people didn't want it there. It was, we didn't feel that there was a benefit there because we support the private deployment model. Getting locked into the framework ship cycle turned out to not be all that beneficial to us. So that's why we don't ship in. I'll show the private deployment models in my Compact talk tomorrow and how you can very easily just add these DLLs. And we showed the RAD configuration with the designer in 2008, aggregating sync services in SQL Server Compact, and so forth. We've got the CTP for the next additional functionality of sync services coming. And again, the architecture here, so I don't think any of you guys are willing to get rid of your refrigerators anytime soon, or your pantry. You know, there's definitely a need there. Toilets have water right in the tank. You know, there's just everything about these models are all about bringing resources, caching them, sending them back. And that's just the way things are. Why are we fighting this with technology? It's really an evolutionary step. Now, you can do this to your existing apps, or you can build this into your apps as you build new ones. Both approaches work fine. If you're online, things just work great. If you're offline, it's going to work better. And just because you have a burping network or a bigger problem, you're going to be productive. You know, we had a 3-day power outage in Seattle. I happened to have a generator from something else, and I just kept running. My kids were playing Xbox on their big screen TV. My internet actually happened to work. I was actually kind of bummed. I was hoping to get them off the Xbox. But completely uninterrupted. So it's just a matter of where you want to kind of take this. Now, there's a lot of resources available. Rafiq, our main dev, has got syncguru.com for the sync services stuff. We've got the Sync Dev Center we've just launched. SQL Server Compact and Q&A, and Bill Vaughn actually has a book on SQL Server Compact there. Sessions that are coming up, so sessions that were already happened for what Philip talked about this morning with introduction and SQL Server Express, which I covered yesterday. And unfortunately, because of timing, Neil was giving the talk on how to write a custom provider now, but we have some other sessions coming up as well. And definitely come visit us by the booth. Please fill up your evals. We'll stick around and answer some questions. Definitely appreciate the feedback, both constructive and what you'll really like. That's also helpful too as well. But it really helps to fill in the details so we can actually know what to do. So with that, I'll take some Q&A, and thank you for the talk. there any questions? Yes. Yes. So the question was, he saw sync group on the client configuration. And absolutely, it's all about how you can control how much information should be sent up to the server. It's interesting is that it actually works on both sides. So as I was talking in the hierarchical update scenario on the server actually should control how updates are applied, right? Orders, order details. But the client could say, I have 10 tables. I only want to send up a couple at a time. So you can actually batch them in a sync group. And I could say, I want to send customers, orders, order details, and products. And I could split those up into batches that get sent up to the server and then applied in a transaction. So if that connection drops, you can still get smaller groups of them set up. So that's how the sync group works there. Anybody else? Yes. So the question was, how does it handle the ordering and the relations between the tables? Absolutely. So that's the other half of the sync group conversation. So the sync group was used on the client, and on the server, we have the DB server sync provider, and you add sync adapters to that in a collection. And in that collection is how we kind of do the inserts, updates, and deletes. So we'll actually do deletes starting from the last thing in the collection, moving up, and inserts and updates from the tops down. So we actually will do it in that order. So we can, so in this case, we actually don't even require a foreign key relationship. We can leverage that sometimes to put it in the right order, but as long as they're in that order, that's the order we'll apply them. There's a gentleman in the back, yes? I'm sorry? With, workflow foundation. Not at all. So workflow, the question was how does sync framework related to workflow foundation? So workflow is much more, I'm not a workflow expert, so I won't try to claim a lot of details of it, to be fair. But workflow is more around how do I move business logic in a process through a pipeline, so to speak. To some extent, sure, that could traverse across. With the sync stuff is we're actually trying to move the data. Now the data might work from workflow on this side to workflow on another side. You need to kind of synchronize the payload between the two. And you can absolutely picture a scenario where both are being worked together. But they're not meant to be competitive products. They're more a matter of just like, in many ways, SQL Server Compact and Express, they're not meant to be competitive products. They're used for different scenarios that have some amount of overlap. I'm sure there's some amount of overlap for workflow and synchronization as well.
Wait, excuse me?
Oh, yes, there he is.
Which editions of SQL Server 2008 will change tracking be available in?
Yes, so we've actually going to have change tracking available in all versions of SQL Server 2008, including Express. We were debating that a bit, but we decided to put that in Express as well. So you'll actually be able to use Express as the server. In fact, what I was showing here was SQL Server Express. In this case, it was 2005, but it could have been 2008. And we'll automatically configure in our next release, probably in our service pack, we're going to hopefully get the designer to know it's SQL Server 2008. So instead of generating those tracking columns, we can generate the scripts for enabling change tracking. But in the client, so SQL Server Compact has change tracking in it already. Which we added in 3.5 was the change tracking feature in SQL Server Compact. We're going to add that same change tracking capabilities in SQL Server Express as well. I got a different look from you when I said something there. Well, SQL Server Compact, so with SQL Server Compact, we already have change tracking in it. It's a different implementation than SQL Server because we're trying to get a smaller footprint. When you make changes to the local database, we're tracking those. Well, we happen to use, but it's an internal one. It's not a user column. You can't see those. If you drill in, you can see the system data. But we're already tracking that stuff. There's no additional user data shown on the tables. No, it's not on all tables. So the question was, is that tracking always enabled? And the answer is no. When you enable change tracking through the sync runtime against SQL Server Compact, it's configured. But it's not, so you can kind of opt into when that's put on. So we already have the change tracking SQL Server Compact in 3.5, and we'll be adding that to SQL Server 2008. So SQL Server Compact 3.5 might as well be SQL Server Compact 2008. We didn't call it 2008 because we ship too often. So we'll be shipping another release before the next release of SQL Server. So we've broken off and decided not to use the year moniker, but it's part of our Cat My Release wave. There's a question over here. I'm getting ricocheted, and I got this guy right here, so go ahead. Yeah. I'm sorry, the provider? The provider supports messaging? I'm sorry, I don't understand. Oh, reliable messaging. So reliable messaging of WCF? Or are you talking about? So the question is, does the framework support reliable messaging? Reliable messaging is a pretty complex problem. I'll kind of set it up with that. WCF has reliable messaging built in, you have some options there. So when you're synchronizing and using WCF reliable messaging, you can hook into that as well. We definitely use transactions when we're getting and setting changes in the databases on either side. So again, we're trying to not pretend to own the entire stack and leverage the other protocols that are available. So you can definitely get that kind of messaging, but we don't depend on reliable messaging. So we wanted to make sure that we can work over just plain old web services. And if a middle of a web service, if the thing dies, we wanted to make sure we weren't in a broken state. So you can take advantage of reliable messaging, but we're not dependent on it. Okay? And yes?
Using a service
instead
of a database.
Yes.
In that case, how the tracking happens? I mean, is it that the entire data gets synchronized, or the increments that get synchronized?
So the question was, how did it track changes when it was running over a service? It's kind of so the same way in two-tier, when the components were on the client, it ran queries against the server. You saw the T-SQL queries, right? And it brings those results back. We happen, in our APIs, we happen to use dataset because dataset just works. We didn't want to invent yet another payload here. So the dataset was able to just be passed around, and dataset has row state. It's got schema definition. So we were able to use that as the payload to bring it across in the two-tier. In the n-tier, all we did was leverage the dataset serialization for it to send it across the wire. So all the changes are still being tracked in the server. The commands are still running the exact same way. If you're fine with dataset serialization, that's what we're able to use. If you're not fine with dataset serialization, you can convert it to whatever you want. There's no hard restriction. You just need to have matching pairs on both sides. So it was the same exact infrastructure. We just said between those 2 points, stick a WCF service and a WCF proxy. Okay? So it's the same exact change tracking infrastructure. What's interesting, though, is we have customers that say, hey, I've got Oracle and I've got Java on the server. I can't use any .NET technologies on the server. But I got my users that want to work in the field, they want to work offline, so I'm writing a WinForms app for them. How do I work with that? On the server, you can write the change tracking against Oracle. We don't care. You can use .NET or you don't have to. You get a payload. That was the jelly beans thing, right? You send jelly beans to the client that represent the data, completely whatever you want to do on that side. On the client, you convert those jelly beans back to a data set for us that's how we know what data to put in and out of the database, and you're perfectly fine. So you can use smaller components of the sync framework, in this case, sync services for ADO.NET, to use as little or as much. The more you use, the more productive you are. The less you use, that's fine. We'll work with those as well. Is that your question?
And are there any samples or labs that you're published for this particular scenario?
Yeah, so this, I believe, is the lab I believe this lab's here. I'm sorry I can't answer that specifically. I believe that lab's here. On my blog, I show screencasts of the same thing. On the syncguru.com site, Rafiq has got samples of it, and we have hands-on labs specifically around this as well. And their docs talk about doing this as well. Anybody else? Yes. Will I have a? Sure. So the question is, I have a really, really big terabyte database, and I don't want to sync the terabyte database down to the client. How do I get a piece of that? Right? Yeah. So you can, because they're just T-SQL statements, right? Sprox, views, whatever. You can write select statements that are some of the columns. You can write select statements that have a where clause that bring in just some of the rows. You can join across a dozen different tables and bring down just that subset to the client. On the sync agent, on the client, there's a sync parameters property that you pass in name value pairs that can represent the values of the parameters that the server can use to bring down and to be the values on your where clauses. So you can get all of the filtering, as complex and difficult as you want to get, it's all available for you. So absolutely. The trick with those is figuring out what is the data. You know, all right, this salesperson has a set of customers. They have a product line they sell. You know, after they've sold, orders to this customer for 3 years, you need to have the 3-year history on the client. So I can delete stuff on the client and make sure it doesn't get deleted on the server. So you have a lot of flexibility in all of that. Those are all definite core scenarios that we built in. Anybody else? Yes.
Is there any provision in the framework to recognize, let's say, batch update mode? For example, to make a distinction between when one row is deleted or 1,000 rows deleted from the same table.
So did I hear batch? Is that what the question was? Related to how I can bring batches down?
Well, it's not that batch in the true sense of that, but just the idea of you may have one record or thousands of records in your, let's say, update table.
With a change set.
Yeah, and is there any optimization available built in the framework?
So one of the things that we added, which I think will be the answer, and if it's not, tell me it's not. There was times where people needed to bring down, and 1,000 would be probably pretty easy still, but let's say 10,000 rows. And I don't want to get 10,000 rows in one batch because my network might be really slow or whatever. I want to break it into smaller chunks. So we have the ability to break that down. And in sync services for radio.net, we have anchors. They're just incremental values. Could be a date, could be an integer for a timestamp. You could say, I know I have 10,000 digits between the last time I synced and what the current server is. I'm going to break it up into 10. So now I'll get 1,000 and chunk it. So you can definitely break it up and bring that down to the client. The batching is a little bit more advanced because we just didn't get the time to surface the API in the cleanest way, but it's absolutely supported and absolutely part of that scenario. Is that kind of what you were asking?
Yeah, it's one part of it, and
okay.
the other is it still will perform, let's say, 10,000 of operation, right? Instead of, let's say, changing it to delete from where, yeah?
Oh, I see what you're saying. So on the server, you did a delete for 10,000 rows, and you really don't want to sync the 10,000 rows deleted. You just want to sync the delete statement.
Yeah, kind of.
So no, directly we don't have that. You can actually, it would try to bring 10,000 primary keys down to the client. But again, you can kind of do that because you saw with the service stuff. You can break that up, and you can just make it part of your service call. Right? You can figure out that, hey, there's 10,000. I have some logic there, and it just returns it back. Okay? So I'm getting blinked. I need to wrap up. I'll stand around and answer questions. And we certainly have the booth. So thank you again for coming, and hope it was helpful.